Greetings, Earthlings. My name is Zero Jake, and welcome back to Space Engineers. It's a lovely sunny day in low orbit. We're currently standing on the supply station we created in the last episode, and the goal of today's episode is to create a shuttlecraft that can transport supplies from this cargo station over here down to our lunar base. Now, things I've done in the previous episode, I've done some mining. I can't remember if there's actually any ores in here. Let's have a look. Yeah, we've got a bunch of ores, and for some reason less than 10 grams worth of steel plate. No clue why that's there. And we've got our mining ship here from the expeditions. Yes. So now that the supply station is here, we can mine and return here instead of to the lunar surface, because that's kind of dangerous. I've also built this connector port, also known as the shuttle port. We're going to get the interplanetary shuttle to connect to this dedicated port so it doesn't hit anything else. I also tried to get a laser antenna system, but it didn't seem to work, mainly from what I've done some researching on, because of the level of detail of the planet. It unloads, and then the laser antenna down on the surface is underneath the surface of the moon, which means that it counts as not being able to connect. There were some reports that using the shield system meant that if it was inside the shield it didn't work. I built one outside the shield, still didn't work. So we're just going to use mutual radio antenna distance, at least for this connection. Right, let's get down to the surface and start building. Okay, before we get started, we have one last thing to do. I've done some retrofitting of the military escort since its turrets disappeared. I've added a couple of thrusters in key locations just to increase its ability to maneuver, and we've equipped it with 2 Gatling turrets and an assault cannon turret. So 2 Gatlings on the other side, assault cannon at the top. It's not as powerful as it was before, and we can certainly upgrade it once we get some new weapon technologies, but until then, well, we're going to have to settle for it. So let's get that constructing. Now with that sorted out, I'm going to start building the ship. It's got some maths behind it, so I'm going to go through the explanations for you, but I'll be building it in the background and you'll have some kind of presentation. Now, on to the other me, I guess. Okay, the main thing we need to figure out when building the shuttle is how much thrust do we need to escape the lunar gravity. In order to work that out, we can look to Newton's second law. Force is equal to mass times acceleration. In short, the thrust we need is dependent on how much mass we want to carry and how hard we want to accelerate it. Let's work out the acceleration first. We're inside the lunar gravity well, and at the surface of the moon it is pulling us down at 0.25 Gs, or about 2.45 meters per second squared. In order to escape the gravity well, we must therefore be able to accelerate faster than 2.45 meters per second squared. For the sake of convenience, we shall aim for an acceleration capability of 6 meters per second squared when fully loaded, which should give us at least 3.55 meters per second squared of acceleration when launching from the lunar surface. Next, we need to work out how much mass we're moving. We want this shuttle to carry 1 large cargo container worth of ore per run. To do this, we will need to estimate the dry mass of the ship, i.e. the mass of the ship without any cargo on board, and calculate the mass of 1 large cargo container worth of ore. A large cargo container can hold just under 422 kiloliters of ore. We know that a kilogram of ore in Space Engineers is 0.3 liters per kilogram, meaning it has a density of 2.7 kilograms per liter, roughly. Taking the density and multiply it by the maximum volume, and we get a mass of 1,140,000-ish kilograms. Now that we've worked out our constants, we can make a spreadsheet to solve the rest. Here's a spreadsheet I made earlier, because that's what we do here on Blue Peter. We've got the relevant statistics of some key components. We've got our ion thrusters, we've got our reactors, cargo containers, we've got a column for mass, we've got a column for thrust, we've got a column for power generation and consumption, generation being positive, consumption being negative, and the last column is where we can alter how many of each block we have on the ship. Now, this isn't taking into account the gyros, conveyors, armor blocks, etc. that we will have, but this will at least approximate what we're looking for. Down here, we can see the maths. The total mass and thrust just grabs the quantity of each block and multiplies that by their relevant values. Surplus power is here to keep track of the power requirements of the thrusters, since that will be a constraint we all need to deal with. Lastly, we have our predicted acceleration. To work that out, we can rearrange Newton's second law from force equals mass times acceleration to get acceleration equals force divided by mass. We want to make sure that this value is above our target of 6, and that we're positive on our surplus power, ideally by using as few resources as possible. Now, we could add the component or ingot cost of each block in here as well, but we're not looking for that degree of specificity, and I'm already running out of time to edit this video. Monkeying with the numbers, because I've done this earlier, we can see that 2 large thrusters and 5 small reactors are enough to achieve our goal of 6, whilst not being too far over our surplus power. Now that we've figured that out with the power of science, we can return to the game. As you can see here, we have the welded bare bones of the ship. We'll add some armor blocks over it later, but for now we need to give it a test run. Right, let's go, shall we? Look at that acceleration. It's ludicrous. So, since we've taken out a lot of our platinum supply by making all of these thruster components, we are sorely low on it. So we're going to grab the platinum from the base first. Right, let's get ourselves into a nice position. I don't know why the screen keeps going dark on me. Right, there we go. Rotate. We might want to add a couple of regular thrusters in the front and backward position, just so that we can use it for fine maneuvering. There we go, that's connection. We're going to park, and then we're going to get ourselves inventory. Show inventory on ship only. Yes, we're going to want to fix that. Why does the control seat have its inventory displayed? It really shouldn't, because it doesn't have anything connecting to it. Right, let's get ourselves platinum. Let's get ourselves the cargo container and get as much. We might as well pick up everything. So we've got lovely amount of gold, lovely amount of platinum, bit of iron. That steel plate can just disappear for all I care. Right, then we disconnect. Get ourselves some distance. We reconvene to the surface. Or rather, we angle ourselves to the surface. As you can see, it's ever so slightly off the 90 degree. I mean, we could accelerate down this way and kill ourselves on the base. But if our calculations are correct, we should be able to decelerate once entering the lunar gravity. Now, of course, once we have an autopilot for this, it should be quicker, and it shouldn't crash into the planet, though I am holding my breath for that. I'm going to do some testing first. Right, let's get ourselves up here. And inwards. Yeah, connected? No, we're not. No, we aren't. Let's get ourselves... There we go. And then we just park, and everything's all right. So everything in our cargo container should be thrown into the cargo, yes. If Tim decides to wake up. Curious. Yeah, I think I know. Let's get ourselves connectors. So we need to put Tim dock enable on this one, and also Tim dock enable on this one. And then our cargo will go into the system and do all the things it needs to. And then let's get ourselves our reactors, which are split up for some reason, and we're going to put Tim uranium. No. Let's just copy this, shall we? copy, paste. Let's have each of them have 10 uranium. It's a short-ranged craft, so we don't need it to go all out. And then just copy and paste those. Right, which means that every time we dock with any station that has uranium, we will ask for 10 uranium and receive it in our reactors, and we will deposit all of our inventory into the cargo containers. Excellent. So we hop out for a second, get over to our little supply station. We should be able to see that we've got a lot of ores being processed. Cool. Now, we've got a shuttle that works. I'm going to spruce it up a bit so that it looks presentable. Okay, there we go. That is our lovely supply ship. Well, supply shuttle, ship, whatever. I'll come up with a name in like 10 seconds. Constructed with armor plating. I've essentially made it look like a smoothed brick. Like everything else I make. Right, let's go get it up to the orbit. Because it's no good down here. Absolutely no good. It needs to be in orbit for it to be of any use to us. So, let's do that. Now, we're going to need to test some different methods for automation, at least of this route. And I'm not comfortable in doing that in survival mode. So we're going to hop over to a creative save and start testing. Now, most of this testing was done to work out any issues that would arise from handing over control of the ship to the autopilot. Like that one. Oh, God. Now, unfortunately, the autopilot feature that's inbuilt into the game using the remote control block does not have the finesse to auto-dock with a connector, so we will have to look to the wondrous world of scripts. Today we'll be using Spug's Easy Auto-Docking 2.0 script, a script that pilots the ship to a previously designated docking point. I'm going to briefly go through setting it up here, but you should really check it out, link in the description below. Okay, so now that we've got that figured out and gotten rid of the bugs, I have done a couple of additions. That's better you could do, whatever. First of all, we now have this conveyor pipeline that leads to a docking port outside of the main walls, which is dedicated towards the shuttle. Secondly, we've put 4 timer blocks onto the shuttle itself, which will help with the programming nonsense, and a programmable block on the underside. Now, it's very simple. I've rigged it all up, and now all we need to do is program in the positions, which I'm going to do right now. Right, so first of all we want to name this place, which is going to be LBA, short for Lunar Base Alpha. I mean, it says Zero Protocol on the top left, but ignore that. We're going to run that. Or alternatively, I actually need to add the script in. That would be a good idea, you fool. Okay, awaiting orders. Save this as doc. Good. We are then going to disconnect. Back up a bit. Also go to the bit to the right. And we're going to get a record point somewhere, let's say about 700 meters above the ground. So the way that this system works is when I tell it to go and dock with the base, it will first of all come to this point. So let's get this, set it as record. So we get the programming to start recording these waypoints. We then set the one that we're recording for, which is LBA, and then we set empty so that it will add 1 waypoint. Then we shall descend closer and try not to break anything, because I did that a lot. So we want to get something that's nice and lined up like this. Then we go into the programming block again. And we're going to run it empty again, which adds a second waypoint, and then we just need to slide in and dock. And then we need to get the auto dock 1, and then run it again. And it will say finished recording. Good, which means that if we undock, and we go into here, and we go, hey, we want to go, let's put in read only so it doesn't screw anything up. We want to go to the Lunar Base Alpha. Run. It's going to go off to that first waypoint. The maximum speed that this goes is 100 meters per second, which is completely fine. It's going to slow down. So it's going to hit 0 velocity hitting that point. Then it's going to accelerate downwards and decelerate once it gets too close. And then it's going to move in and park. See? Simple. Right, now I just need to set the one on the supply station. Okay, there we go. We've docked with the supply station. We're going to go get the autopilot. We're going to set this as LOSS, standing for Low Orbit Supply Station, Lunar Orbit Supply Station. There are many things that you could say with that. Run this, saved it as location. We're then going to undock. And because we want to start our recording to dock here near the surface so that we clear the tower properly, we're going to go back. Read only. We're going to go back and run the script through from orbit so that this works properly. We're going to go back down to the surface and then start recording our ascent up to the station. And then once those recordings are done, everything is set and perfectly fine. Okay, right. We are now at the surface. We're going to head off just a bit. Then we're going to get open our programmable block. We're going to go, hey, we want to record. We want to record for LOSS. Cool. We want to set this as the first waypoint. We want to then go upwards. We're then going to go up to the waypoint, or we're going to go up to the dock itself. We're going to align with it. We're going to go down about 200 meters and then set that as the next waypoint. No, that's not the place I'm supposed to be. Here. No, here. Yes. Run. Going to back up again until we're perpendicular. Yep. Run again. And then dock. Run. There we go. Finished recording. Nice. So what does this mean now? We can dock here. We can then see that there is absolutely nothing of value inside here, so we're going to be doing a dry run for this. We get out. I'm going to set myself to have inertia dampeners enabled. Relative inertia dampeners anyway. We're going to... let's access here. I'm going to need access to... yeah. It's not going to work exactly as I intend, but say we're controlling the station. We then go, hey, I want to launch this ship. We go to the remote control, we go into the control, and we've got two buttons. Well, I've got four. We've got one that activates the autopilot to go to the lower, the lunar base, and one to go to the space station. Well, we want to activate number one. It's going to disconnect, and it's going to descend. Really? Yeah, I didn't program that correctly, did I? Okay, so I've done the reprogramming, and everything should work this time. Let's try that again. So, exit the... no, hang on. So, park. Yes. Exit the ship. We go up to the control station. We then enter the remote control. Okay, good so far. We then press 1. Disconnects from the connector. Aligns itself and heads downwards. Now this is the moment of truth. If it fails us here, then I'm going to have to rebuild it. It shouldn't. But, well, I did encounter the error with the not having placed the waypoints correctly, which is why we had our previous accident. Okay, Final approach. Oh god, slow down, please. That's how much ground clearance we have, by the way. It works. Oh, that was... So basically, if there's an error in the code, or if the code stops working and it decides to continue plummeting, well, actually, it should enable inertia dampeners if the remote control, or rather, if the overrides from the programmable block disengage. But if the programmable block gets sniped mid-transaction, or mid-transfer, then the thruster overrides won't be turned off, and so it will just plummet into the ground or go hurtling off into space. What's the fastest velocity we can get to? Like 500? 1,000? I can't remember what I set it as. But yes, that is a orbital shuttle that now works. Now the real test is we need to get a heavy load of ore and have that transferred down to the surface. Okay, so we've just come back from a mining mission and we've got a large cargo container worth of ores. So we're going to go in here and we're going to deliver the materials to the surface. We should be all packed up and loaded, just need to get one more. Let's get as much stone as we can carry. There we go. So now we're going to enter the remote control. We could technically do this from the ground as well because we're in mutual antenna range. And then we're going to control from here and we're going to go to the surface. Interesting. You're not firing. That should be... Interesting. One of the thrusters on the left-hand side doesn't seem to be firing. Shouldn't be that much of a problem, though. Right, and then we just watch carefully as this thing tries to decelerate within lunar gravity and hopefully does not crash. I'm going to get out of here in case the bad things happen. I want to see it explode in spectacular fashion, as do you, I imagine. That is, if it does fail. And that's why we're having it park outside the base, so that it doesn't make a massive mess, and then we have to clean it up. Instead, we can just let it sit there as a wreck, a testament to our failures. Okay, we're going in for final approach. You're going a bit fast there. Have you accounted for the gravity? Perhaps. Perhaps not. Okay, we're on the suicide burn. And we are there. And there you have it. We have an orbital shuttle that works. It's programmed, which means that it can't fail by human error. It can only fail by technological, which is far less likely to happen. And all of those materials will go through this docking port into our lovely refineries and start being refined. Good. That took too long. Like over 5 hours of making that work. But as you can see, we've got iron, gold, silicon, stone, uranium. It's all good. It's going to take a while to refine. I should probably add more refineries. One building doesn't seem to be enough, and we've got plenty of space for them. Maybe have them built outdoors this time. They don't necessarily need to be indoors. But I will do that at some other point. Until next time, my name has been Zero Jake. End transmission.